Hello, my wonderful people. Hope you are great and safe. Uh, Today, I intend to talk about something new and rare in field of telecom hacking. So, it's really hard for security experts, uh, telecommunication engineers, and mobile operators to deal with signaling and telco attacks. Why it's hard? Because telco networks are complex and includes many segments like radio, signaling, IP backbones, IT packets, packet data actually, etc. And in this talk, I don't want to talk about basics and traditional tags. I just want to illustrate how we can break into a hardened telecom infrastructure, why they are using security devices and security mechanisms. If you are ready, let's get into it. First of all, I want to introduce myself. I'm Ali, a cybersecurity researcher focusing on all aspects of offensive for more than 8 years. I'm author of books and articles as well. I'm a regular speaker and trainer at international conferences, holding Master of Computer Science and many international certificates. Okay, as you can see, according to the news, this slide, many fraud, other types of cyber incidents have occurred in past several years while they're abusing telecommunication and mobile infrastructure. In top left corner, you can see that malefactors exploit SS7 network to inject a malware to attack on financial companies and banks. In other news, on the left side, you can see that hackers targeted UK Metro Bank through SS7, which is the SS7 is one of the main signaling protocol, or to stand for signaling system number 7, and play a critical role in telecommunication and actually traditional telecommunication infrastructure. Okay, and on right side there is a news regarding to vulnerabilities in mobile networks in United States. In this slide, I divided all possible attacks and vulnerabilities in telecom. First is subscriber uh, profile data leakage or subscriber data leakage. The second one is network data leakage, or maybe mobile node data leakage. Third one is tracking mobile subscribers and breaking their privacy. The next one is sniffing, spoofing, fraud, like uh, transferring money, using USSD operations, or making free or cheap call. For example, uh, you may make a call to another country while you are paying for the call, like an internal one, or maybe uh, a call to your current country. Uh, so Okay, for those who has not enough background of telecommunication and mobile network, here is the architecture of a mobile operator. Each mobile network operator, or MNO, has three main segments, includes radio access network, or RAN, which responsible for all radio and baseband communications like your connectivity from your handset or mobile phone to the tower. The next one is circuit switch network or CS network. CS core network handles your voice and SMS, something like that. And the third segment is packet network or PS, packet switch network, which is responsible to bring your internet connection. Okay, in this slide, I'm going to talk about security mechanism in radio access networks or RAN. Mostly there are three types of security mechanism in radio access network. First is phone registration or any type of policy for your hardware and IMEI, which is a unique code for mobile hardware. Second is enabling ciphering algorithms to fight against interception and man in the middle attack or MITM. Third item is using only LTE and LTE advanced infrastructure instead of traditional mobile core networks in 2G and 3G. So now we want to review the high level architecture of radio access networks. In radio access network, we have cell tower, maybe you know BTS, in 2G, Node B in 3G, and eNode B in 4G or Evolve Node B in 4G or LTE. You can see that eNode B is passing your traffic to PS, packet switch, and circuit switch networks based on the traffic type. Okay, it means that if you want to connect to the internet, your traffic will go through PS network or packet switch network. And if you want to make a call or maybe send a SMS, the traffic will go through CS or circuit switch network. Okay, so why using IMEI policy? So the answer is to fight against phone smuggling uh, and maybe some lawful and security monitoring, tracking and locating stolen devices and criminals. Uh, okay, now with the help of a phone like Motorola C115 and 118 and Osmocom BB software, we can set an invalid or fake or even duplicate IMEI and set up a call to test network reactions. As you can see in this screenshot here, network sends identity request to my phone and the type of identity was IMEI. Here is the screenshot. You can see the type of identity is IMEI. So I should reply with a, 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 um, a valid IMEI number. So in this slide, as you can see, I replied to it request using an invalid IMEI set to all zero. I think that's cool. And so the network accepted my invalid IMEI because ciphering procedures completed, as you can see. Okay. There are some types ciphering keys like KC, SRS, and RAND or random number in radio access network, which harden a radio network to avoid active sniffing, and they always store in a home location register or HLR or HSS in core network. Actually, HSS or HLR as subscriber database has a components called AUC or Authentication Center, which responsible for ciphering and authentication procedures. To bypass and get this information, we are going to targeting AUC in HLR HSS by uh, please note that when I'm talking about HLR, it means traditional node in, for example, 2G GSM or even UMTS. And whenever I'm talking about HSS, which exactly is like as HLR, HSS uh, is in core network when we are going to talk about LTE or even 3G. Actually, we are going to targeting AUC in HLR HSS by abusing SS7 and signaling access as a roaming partner. Okay, as you can see here, I sent a malicious SS7 map or mobile application part SAI or send authentication info to targeted core network from SS7 network to retrieve ciphering information, and the network respond me via random number, address, and KC values in clear text. It's really cool. Okay, another security mechanism is using LTE, only LTE and LTE Advanced to bring highest quality and performance. Uh, Having more security and privacy in core and radio segments, and other factors like voice over LTE or VoLTE, flexibility, and many others. Okay, guys, let's review bypassing method in this slide. Totally, uh, there is a one general way, and that's downgrading subscribers to traditional technologies like 3G and 2G, which are vulnerable. To perform downgrading, we need to use a signal jammer. Okay, security in circuit switch network or CS core network. First thing is using SMS home routing, and the second mechanism is using signaling firewalls. Okay, cool. Home routing act as a proxy, and the definition of a home router is to hiding subscriber IMSI, which is a very valuable information to perform hacking scenarios from hacker sites. As you can see, a hacker request to receive IMSI from HLR HSS, and the HLR HSS respond with real value. However, home router change the value with a fake one. Okay, first things from a hacker point of view is how we can detect if home routing is enabled or not. Just we need to send two or more malicious SS7 messages like send routing info and even send routing info for SM. If we receive different responses, it means that SMS home routing is in place. As you can see, we have two different attempts here. In first one, a hacker tried to send a malicious SS7 request to the core network, and the core network responds, SMS router respond with a number. So hacker retrieved a number as IMSI. In second scenario and in second attempt, hacker resent the same message to request the IMSI. So as a true result, hacker must retrieve the same value of IMSI. However, as you can see, the numbers are different. So the hacker received different numbers as IMSI. So in this case, SMS home routing is in place. Okay, let's go deeper to bypass this security mechanism. In telecommunication networks or mobile networks, we have three types of GTs or global title, which act as IP address. Okay, MSISDN consists of MCC or mobile country code, NDC, and SN. IMSI consists of MCC, mobile country code, MNC or mobile network code, which indicates your mobile operator code, okay, and MSIN, which is a unique number. MGT consists of MCC, mobile country code, NDC, and MSIN. As you can see, hacker can abuse MGT number and a valid random IMSI number to request other information regarding to targeted mobile number or MSISDN and its real IMSI. So, according to the picture here, hacker tried to send malicious SS7 message to the core network using MGT, and hacker guess a random IMSI located in targeted HLR HSS. It's easy to use because, for example, a hacker could take advantage from a known IMSI like for example, my IMSI, I know my IMSI. There are many different applications that you can try to retrieve your IMSI, or even some online and offline databases on the internet. And again, like previous slides, core networks and actually nodes in core network replied with real values However, SMS home router replied the actual number plus MSC address because hacker guessed NMC, which is valid for the operator, mobile operator, with MGT number. Okay, so the next security mechanism is signaling firewall. Mobile operators use actual signaling firewalls to protect their signaling infrastructure or circuit switch network. Signal packet inspection, filtering, white and blacklisting are main feature of a signaling firewall. So how we can bypass it? To bypass these kind of firewalls, we need just to playing with TCAP. Okay, what is TCAP? TCAP, or Transaction Capabilities Application Part, is a SS7 subprotocol, and it's like TCP. TCAP enables the deployment of advanced intelligent network services by supporting non-circuit related information exchange between signaling points using SCCP, or signaling connection control part, which is connectionless service, and TCAP provides the framework to retrieve information or even invoke remote operations. TCAP offers the means for end users in the SS7 network to query another end office and acts as the software interface between an SS7 office and database services in order to actually obtain data from the SS7 network. Okay, well, to perform bypassing, we need to remove application context name from TCAP. Or the next way is sending double operation message. So I want to illustrate what is application context name. The application context name, or ACN, is used for all supported ITU TCAP message except abort message. No attempt to retrieve the ACN is made for abort messages. All other supported messages may have a dialog portion containing a dialog request or unidirectional dialog response PDU from which the ASN is retrieved. If no dialog portion is detected, then the ACN is assumed to be none. The TCAP opcode-based routing feature attempts to find the operation code or opcode in all supported ITU TCAP message except abort. These messages must contain invoke or return results last or not last as the first component. If not, the opcode is assumed to be none. Okay, removing application context name from TCAP message. To start the procedure, we need to remove dialog request section from our malicious SS7 message before send to core network. Then there will not application context name to point to malicious SS7 map message directly. According to the picture, you can see the hacker is trying to send a normal SS7 message without dialogue, which means the hacker removed dialogue request from SS7 message. Plus, in addition, actually, the hacker put malicious message opcode inside the whole SS7 message. So as a result, CS core responds to normal message, in addition, malicious message. So a hacker retrieve all information that he or she want to have in this case. Okay, sending double operation message. Most of signaling firewall block or accept a message based on message type. So each signaling message has its own operation code or opcode that I mentioned before, and it's a vital number. In this code, in this in this picture, you can see that the opcode of send routing info for SMSI for SM is 45 in this scenario. As you can see here, hacker is trying to put a legitimate SS7 map message operation code in the first step. And then hacker put a malicious SS7 map message. So signaling firewall will check just the first operation code, which is pointing to legitimate operation, and pass through to core network and can address malicious operation and in addition legitimate SS7 map message and malicious map message. As a result, HLR HSS respond with some kind of error because it can't understand what we are looking for. So signaling firewall will keep the whole session to get back any a legitimate SS7 message. So the hacker will try to retrieve and request actually everything that's valuable for it, because the whole session established and signaling firewall is keeping it. So the hacker will take advantage from this actually session, and so signaling firewall treat like the previous one, because signaling firewall keep the whole session and this session is legitimate. So as a result, core network respond with all information regarding to, for example, subscriber MC and network information that hacker requested. Solutions. Actually, first an important thing is hardening the devices, protocols, and communications based on industry standards like 3GPP, ETSI, etc. Most of related vulnerabilities can be patched using hardening and security audit. Second one is using firewall, or if you are using signaling firewall already, you can fine tune and optimize it. A TSOC, TSOC, or Telecom Security Operations Center is highly recommended. Like IT and IP backbones, which need to have real-time security monitoring. Telecom networks need to have something like that. Periodic assessment and audit are necessary. And finally, training and security awareness are very useful. Thank you guys for your attention. You can stay in touch with me, sharing experience and knowledge together, finding more friends, and please stay safe and healthy. And thank you, uh, organizer, for organizing such a great event.